So we start with the first questions. That's the part 1 of the short answer. We have to write the 5 difference between continuous time and the discrete times. We can see that for the continuous time, we can divide it for all time t. But for the discrete, we only can divide it only at discrete time constant, which leads to the second difference is that the continuous time t is the real number, but the discrete time at the end is the integer number. So the third one, we have that the continuous time signal will be periodic when t is equal to 2 pi over omega. But for the discrete time, we have is periodic when n is equal to 2 pi over omega. And the fourth one, we know that the continuous time x of kt will be compressed when k is more than 1. But for the discrete time, we know that the x of kn will be compressed when k is more than or equal to 2. And we can know that the last difference is that the time scaling. For the discrete time, we lost some information. The second question that we have to sketch the yn equal to the half of the x 3n minus 1 plus 1. So the first one, we have to find the x n minus 1. As the n minus 1, we can know that the signal moved to the right for one scale. So we have to move this xn to the right. We can know that the x of n minus 1 is equal to this signal move to the right, but the magnitude is the same as the xn. The next step, we find the x3n minus 1. So we have to divide it in by 3, like this one n is equal 0, 1, 2, and 3. Then we divide it by 3. So there's some info that n is equal to the ratio number, like 1 over 3 and 2 over 3. Then we cut them off, so we have only 2 left, like when n equal to 0 and n equal to 3 over t, which is 1. Then we have the signal x3n minus 1 like this. Like we get only the when n equal to 0 and n equal to 3 as the n equal to 1 for this signal. Then we multiply it by 1/2 or 0.5. Then as the previous, we have the magnitudes of -1 and -1/2. So we multiply it with 0.5, which change to -1/2 and -1/4. Then the final signal, the yn, we have to pass the magnitude with 1, so the other with the 0, we got it 1 like this. And the other two with -1/2, we pass it with 1 and we got 1/2 positive, and the -1/4 we got 3/4 like this. This is the final answer. The third question, we have to prove this equation. Like I start with, let a equal to this one, which is t minus tau, and we got dA equals to minus d tau. Like after that, we start integrating this one from 0 to minus infinity of the delta t minus tau d tau from the equation, and we substitute this. Like we got the delta of a dA with the minus sign, and then we have to rewrite the interval. Like as the previous, we have 0 to plus infinity. Now with the dA, we have t to the plus infinity, and then we take the minus sign, so we got minus infinity to t of the delta a dA, which this one is equal to 1 when t is more than or equal to 0, and we got the 0 otherwise. For this value, we can prove that this integration is equal to the unit signal ut. For the first question, we have to find the output of the inputs of x of n, and we know that the yn is come from the delta convolution sum with hn. Like we know that when the delta with the h, then we have the table like this. We have delta and the value of 1, and the hn is 0, h1 and h2. We got the yn equal to 2 minus 1 and 1 like this. Then for xn, we have to find the multiplication between x and h. So we can create a table like this. You know that x has the value of 1, -1, and 2, like 1, -1, and 2. Then the hash is from the above value, which is 2, -1, and 1. Then we multiply like this, and this. Then we got 2, -1, and 1. Then we multiply like this, so we got -2, 1, and -1. The last one we got 4, -2, and 2. That is, after we got these values, so we have to find the x n minus k, which is, when we got this xn, we change it to xk, and then we shape it with the n. Like, we can know that we're reflecting the xk. Then we got something like this. This one is look like x minus k, and then we pass with the n, so we got x n minus k with the axis of k value. Then we know from the previous that at this point n is equal to 1, right? So we pass n to the signal x minus k, so we got this point as n plus 1. Then we find the first overlap point. So we have to move this signal to this one like this. And the first overlap point is that when we move is like this, and we know that the n plus 1 is equal to 0, and we got n plus 1 equal to 0, or which means n equal to -1. Then the first point is y minus 1, and we got to sum this value, which is equal to 2. The next one, y 0, we have sum this one, which is -2 minus 1 equal to -3. y1 is equal to sum of these value, which is 4 plus 1 plus 1 equal to 6. Next one is y2 is the sum of -2 minus 1 equal to -3. And the last one, we have y3 is equal to 2. The next question, we have to prove this equation. Start with the xt convolution with the h1 with h2. So we just group the new group like a switch pairs like this. And then for the definition, we got the integral from -infinity to the infinity of the h1 tau star the h2 tau dot with the xt minus time. d tau. And then we do the definition for the h1 and h2, which we got the integral of minus infinity to infinity and the integral minus infinity to infinity of h2, let's call it k, and h1 tau minus k dk time with the x t minus tau d tau. There's the two integrals. Next, just new regroup. We have h2k here, and then the integral minus infinity to infinity h1 of u, let's call u, and x of t minus k minus u du dk. Then we got something like this. h2k the same, and this one become h1 t minus k. Start with the x t minus k d, oh sorry, dk. And then we have the same k, right? So we can call that is equal to h2t convolution with the xt, which h1. Part 2, true or false, and then state the reason. First question, let x e t be even part and x naught t be the odd part of xt, and then it says that x0 equal to x of the odd part of 0. Then the first we have this equation like xt is equal to the xet plus the xot, like this. It's a combination of the even part and the odd part, and then we substitute t with the 0. We got x0 with the xe0 plus xo0, and then we know that the xo0, the odd part of 0, is 0, so we got x0 equal to xe0, which means false. Then the second question is that the fundamental period of the signal xn of exponential of j4 pi n over 7 plus exponential of j2 pi n over 9 is 63. First, we know that the first one and the second one. Then we know that the omega 1 is equal to 4 pi over 7, and we compare it with the 2 pi m over n. Then we got the value of m1 equal to 2 and n1 equal to 7, since it's equal to 2 times 2 pi over 7, right? Then we got 2 and 7 for m1 and n1. Then we know the omega 2 is equal to 2 pi over 9. Compare it as well with 2 pi m over n. Like we got m2 equal to 1 and the n2 equal to 9. Since it's equal to 2 times 1 pi over 9, right? This is 1 and 9. Then we got the value of n equal to 7 and n2 equal to 9. Then we have to find the LCM of 7 and 9, which is equal to 63. So our period, fundamental period, is equal to 63, which means this one is true. The third question said that the signal xt equal to 2 exponential of j2t is power signal. Then the equation of power is equal to p equal to limit of t to the infinity 1 over 2t, and the integration of minus t to t, and the x square dt. Then we have to find x squared, which is equal to the absolute xt square, which we know that is equal to 2 square, which equal to 4. Then we got this one equal to the limit t to the infinity of 1 over 2t, and the integral from minus t to t of the 4 dt, which we can find that is equal to the limit t to the infinity 1 over 2t with t plus t. Then we got this one equal to the limit t to the infinity 1 over 2t integration of minus t to t 4 dt, which is equal to the limit t to the infinity 1 over 2t times 4 times with the t plus t, minus. Then this one is equal to 2t, which can cut off. Then we got the p equal to 4. Then we know that when p is more than 0 and less than the infinity, this is the power signal, so this one true. The last one, the output of LTI system can be obtained as the convolution of the input and the impulse signal, which is false, since we have is like the impulse response. For question number 2, we have to determine whether it is memoryless, casual, stable, time invariant, linear, and invertible or not. So we start with the sub question 1a. The first one is the continuous time signal equal to the yt1. So we have to first find, like, is it memoryless? We can know that the memoryless signal is hard to depend only on the present value. So since it depends on both past, present, and future, it's not memoryless. Causal signal is hard to depend only past and present value, and this one is depends on future value, so it's not causal neither. The third one, we have to check if it's stable or not. So we have to assume that the absolute of the xt is less than or equal to mx1 and less than the infinity, like it can be defined. Then we have the absolute value of yt is equal to the absolute value of x2t, which is equal to the mx. So we know that yt is absolute less than or equal to the mx, which is less than infinity. So this one is stable. And then we have to check the time invariant. We start with given y1 is equal to minus infinity to t of x1 to tau d tau, and we got the value of x2t is equal to x1 t minus t naught. Then we get y2t is equal to integral from minus infinity to t of the x2 to tau d tau. Then we let 2 tau minus t0 equal to 2t. Since we got the x2t equal to the minus infinity of t of the x1 to tau minus t naught d tau, then we let this one equal to 2g to be easier. Like we got 2 d tau equal to 2 dg, then the d tau is equal to dg. Then we can know that g is equal to 2 tau minus t naught over 2. And when tau is equal to minus infinity, we got g is equal to minus infinity. And when tau is equal to t, we got g equal to t minus t naught over 2, like this. Then we can find that this one is equal to the integral from minus infinity to the t minus t naught over 2 of the x2 to g dg, right? And then we have to compare the y2 to the y1, which is we compare with y1t minus t naught, which is equal to the minus infinity t minus t naught x1 of 2 tau d tau. Since we substitute t by t minus t naught, and then this one is equal to minus infinity t minus t naught of x1 to tau d tau, which is not equal to the y2t. Then this signal is not time invariant. Then we check the linearity of this signal. So the linearity, we have to define x1t can get the output of y1t equal to minus infinity to t of the x1 to tau d tau, and the x2 get the y2 equal to the integral of minus infinity to t of x2 to tau d tau, and then the xt we define is equal to the ax1t plus bx2. Then it can lead to the output y3 is equal to the minus infinity to t of x3 to tau d tau. Since we let the x3 equal to ax1 plus bx2, then we got this equal to this one, ax1 to tau plus bx2 to tau d tau, and we can separate into a integral minus infinity to t x1 of 2 tau d tau plus b integral from minus infinity to t of x2 to tau d tau, and then we can see that this one is equal to this one, and this one equal to this one, which we can relate it as a y1 plus b y2 equal to the y3, which means this signal is linear. And since we know that invertible, that the output can be converted into the input, since this one we know that we cannot convert them, so this one is not invertible signal. We continue on the sub question B, which is the discrete time signal one. First, we check the memory list. We know that memory list is depend only on present value, and this one is depends only on present value, so this one is memoryless. And since it's memoryless signal, so it is casual also. Then we have to check the stability. Then we start assuming the absolute value of xn is less than or equal to mx less than infinity, and then we got the y value is equal to absolute value of 2xn, which is less than or equal to mx. Then we know that the yn is less than or equal to mx and define, so this signal is stable. Next, we have to check the time invariant. First, we have y1 is equal to 2x1, and then we define the x2n equal to x1 n minus n naught, and then y2 is equal to 2x2n. Then we check if y2n is equal to y1 n minus n naught or not. Then we got this 2x2n equal to 2x1 n minus n naught. Then from this equation we define x2 equal to x1 n minus n naught. Then we got this one as 2x1 n minus n naught, which is equal to 2x1 n minus n naught. So this one is time invariant. Next we have to check the linearity. So now we have x1 that lead to y1, which is equal to absolute value of 2x1, and with the same manner on x2, which lead to y2 equal to absolute value of 2x2. Then for the x3, we assume that it is equal to ax1n plus bx2. Then it will lead to y3, which is equal to absolute value of 2x3. Then we substitute the value of x3. Now we got absolute value of 2ax1 plus 2bx2 then we can see that the y3 is not equal to the absolute value of ax1 plus absolute value of bx2. We can conclude that this system is not linearity, and since it cannot convert into the input, so we can say that it is not invertible as well. The last question, we have to plot the convolution integral of the following signal. So we have xt and ht, and we define this one as moving signal, and this one is fixed signals to be easy, right? We can see that xt have simply two parts, like the blue one and then the orange one. Like we know that this one is delta t plus 2, since the t is at minus 2, like we got t minus of t, so we got the delta of t plus 2, and this one is a delta at t minus 2 but a negative amplitude, like this. So we can see that we got the orange part and the blue part, let's say Vt. is equal to 1 when t is more than or equal to 0 and less than or equal to 1, and is 0 for the otherwise. Then we can know that our xt is equal to the delta t plus 2 plus the vt and minus the delta of t minus 2. Next, we need the convolution of xt with the ht, which will be equal to the delta of t plus 2 plus vt minus delta of t minus 2 convolute with ht, which would be equal to h of t plus 2 plus the convolute of vt with the ht minus h of t minus 2. Then what we need now is the vt convolute with ht. Now let's say this one is v tau and the green one is h of t minus tau. Then from this 0 and 1, we now get this one as a t minus 1 and t. Now we need to find the red one. We let it be yt, and as is a convolution integral between v and h, now we can let y equal to the integral from the minus infinity to infinity of v tau with the ht minus tau d tau. Now first one, the no overlap case. The no overlap case has two cases. The first one is we consider on the left. We can see that we have this t, which can be see that we have t less than or equal to 0 to get the no overlap case. And then the next one, we need t minus 1 be more than or equal to 1 to get the no overlap case. This one can be referred to t greater than or equal to 2, and these two cases lead the yt to equal to 0. Next, the overlap case. We can see the overlap part on the left side, and we need that t should be greater than or equal to 0 and less than or equal to 1. And the overlap part is in the interval of tau that greater than or equal to 0 and less than or equal to t. Now we got yt equal to the integral from 0 to t of v tau and ht minus tau d tau. And now you can see that v tau is equal to 1. Also the ht minus tau is equal to 1. Now we get this integral equal to t. Next, overlap case on the right side. As we can see the overlap part there, we know that we need the t minus 1 to be greater than or equal to 0 and less than or equal to 1. Then we got t greater than or equal to 1 and less than or equal to 2. Now the interval. We can see that our interval is from tau is greater than or equal to t minus 1 and less than or equal to 1. Now our yt will equal to the integral from t minus 1 to 1 of v tau h of t minus tau d tau, and it will result in minus t plus 2